Welcome everyone. As This is our inaugural edition of Customer Spotlight webinar series. Our plan is to bring in customers from who have had some real experience running Rising Web in production for a long time to share their thoughts so that others can benefit, not just our other customers, but folks who are part of Rising Web community who are running it in production or evaluating or trying um, to understand what their journey has been, what has worked, what has not worked, how they can be more successful with their stream processing journey. So that's sort of the rationale behind this series. It's not a obviously, as you can see Alex Robin from GDU Labs, is here to explain to in terms of how what their journey has been. So let's get started. Alex, can you go to the next slide, please? First, before we go start the webinar, some housekeeping items. The usual stuff where we've turned off the mic. So any questions if you have at any time, please use the Q&A tab at the bottom in the Zoom menu to post questions. And actually, we want this to be interactive. So please go ahead and ask questions as and when you feel, and we'll interrupt and answer the questions. Alex will answer the question as needed. The webinar is being recorded, so we'll send the slides, so you don't have to take screenshots or anything. So everything will be sent to you. And then if you have any issues with connectivity or otherwise, you can post a question in the chat, and if you cannot hear us, we'll try to address the technical issues along the way. Without any further delay, let's get started. Alex, over to you.
Thanks, Reese. All right. So, hi, everybody. I am Alex Robin. I am the co-founder and CTO of GDU Labs. We're essentially we're a data platform company, and this is the shortest version I could get AI to write here of what we do here. But we take a lot of different data, organization, person, employment data from various sources, and we run it through a data platform to process all of that data together, aggregate it together, and create a single unified representation that we call kind of an entity. Who am I? So I'm Alex. I've been a software engineer or leadership engineering leader for almost 20 years. I live just south of Boston, Massachusetts, in the U.S. About 10 minutes from where the New England Patriots play and where a bunch of the FIFA World Cup games are going to be in the next couple of months. And I've worked at many companies of varying sizes. Listed there, and I've got my LinkedIn and GitHub for those who are curious. Um, and so at a very high level, and I'm not going to spend too much time on this, but I want to kind of share what it is that we do here. And so we take raw data, we buy it, we find it, we acquire it ourselves through first party sourcing, and we for a lot of people that do this, you buy raw data, you have to manually stitch all those sources together. Um, you have to figure out what are the different IDs or keys that you use to merge everybody together. And you have to maintain that data over time. So what we do is we take all that data and we continuously update it, and continuous is a really important word there, um, where we end up with a single materialized entity from those sources that get updated as those sources update their data for us. And so why do we need a streaming platform? Why are we even having this conversation? Why do we work with RisingWave? For us, real-time updates is critical, right? That's a really critical customer goal for us. Customers do not want to wait a day or a week or a month to see updates about the people or the companies that they care about. And it really starts to erode the trust that our customers place in us to show the latest information that they see on social media or in press releases and on the internet elsewhere. If they don't see it within our platform, they get frustrated, they get confused. And so while some of the data that we get is very much batch based, right? We get this data from various sources on some particular cadence. Plenty of data comes in streaming, essentially live. And those updates should come in just as fast as the batch updates.
So,
So what do we?
Alex,
Oh,
a quick,
yep.
a quick,
Go ahead,
a quick
Bryce.
question. Sorry, didn't mean to, but I just, because this is an important point I wanted to understand on the need, right? You mentioned about the criticality of real-time data for you guys at GDU Labs. Is that universal for all use cases, or the specific set of use cases are we talking about here?
Yeah, so a really common one is when you go and you see, say, somebody's employment data on LinkedIn, right? You want to be able to then interact with that data and maybe add that person to like a project that you're working on within our platform, and you want to be able to see that same data. If you see something that's out of date, customers are going to say, well, if I can't trust that data, why should I trust any other data you have that you're not up to date on? And so through various means, we take in data from sources to like as you're browsing LinkedIn, see this data, right, in our platform. And if that data is not shown in a timely manner, we get questions. Why didn't it work? Why do you show data that's not that we don't see on LinkedIn? Or what maybe the better example, why does LinkedIn show data you don't have? Right. That's the more risky scenario. It's much less common for people to say, "Oh, you have data LinkedIn doesn't show." It's more the other way around.
Got it. So, quick follow-up. So, these kind of new requirement that came in, right? For example, folks looking at LinkedIn data and say, hey, we would like to incorporate, enrich, obviously, the profiles. So it kind of, these new requirement necessitated for you to look at streaming, or is it that, like, my question is, picking a new platform is a big question, right? You're going and looking at, uh, you're basically doing, you're looking at the foundations of what your data platform look like. So is it the new requirements that drove, or was it more, you had a legacy solution and then said, okay, I'm going to move to a new product?
That one. We had multiple versions of this in the past that worked to varying degrees. We had systems that were running primarily in more like analytical systems like Google BigQuery, and then more kind of online OLTP based systems that were running in Postgres and everything. And one of the issues that we had that drove us towards this architecture was a lack of understanding of the data lineage, right? Knowing where does data come from. And so we had systems that it kind of did all that more opaquely, right, than the system does, where we have a much clearer lineage of the history of data. And so we, as part of a more holistic rebuild about 2 years ago, we also wanted to take a look at, all right, well, we keep getting complaints from customers that this data takes 45 minutes to show up or an hour to show up, if it does at all. Um, what can we do to improve that kind of time to first, uh, I don't know, first happiness or something like that, right?
Hmm.
To reduce the time it takes for the onboarding process to really get the user into the product, right? And so
Got it.
that's what pushed us towards a more streaming based solution.
Got it. Okay. Thank you.
Yep. So what we're going to talk about today, we're talking about why we chose RisingWave as our tool to implement this functionality, how we did it. It is in our production infrastructure. This is not something that we just run, on in the background and from purely data and analytical purposes. We use RisingWave in a production capacity as part of the hot path for us. Uh, what pain points did we run into? We definitely ran into some, and we wanted to share those and how we mitigated them, and then what we're excited about going forward. So at a very high level, to give you a sense of scale, we're not like a massive data company here, but the numbers aren't small either. We run roughly 3.5 billion events over the last 6 months that affect, give or take, a little, less than 2 billion layers, 1.7 billion layers. And those eventually boil down into somewhere around 700 to 750 million entities. And just for a little clarification, layers are what we call the the collection of facts from a particular source about a particular entity. So a good example would be data coming from, let's say, your like location, right? Knowing that, all right, there's a location out there of Boston, Massachusetts. and it is at this latitude, this longitude, this region, etc. We get location information from many different sources, and we need to make sure that we put all of those together. They're all the same entity, but they can each be updated independently, right? And so that's how we manage the system. At a very high level, we're running in multiple clouds. We use GCP for data flow and kind of data orchestration. That pushes everything through PubSub to our application compute cluster, which processes those PubSub messages and essentially takes those events and processes them onto each layer, right? Each applicable layer. We use AWS for Postgres, among other things. And then we have RisingWave kind of sitting here between the Postgres database and our downstream syncs. Now, those downstream syncs include OpenSearch, right? For which is also running in AWS, Google BigQuery, which we use on the GCP data flow side, and then back to Postgres for application level reads. So definitely some data in terms of how much everyone has their own definition of big data.
No, thank you. This is really good end-to-end view of what the pipeline looks like.
Absolutely. So we're going to kind of dive into that RisingWave box a bit and zoom in there. So why did we choose RisingWave? We really didn't want to make customers wait for these scheduled refreshes more than anything, right? It was a customer-focused problem for us to solve. We definitely experimented with other tools. We looked at Materialize as a competitor to RisingWave. We looked at doing it ourselves through a bunch of asynchronous background jobs and schedules and batches and one-off integrations to other destinations. As you can imagine, that was not appealing to us as a relatively small company. And our prototype, when we did test RisingWave, it just worked. It delivered on exactly what the website said. And so we said, all right, well, let's try it. Let's get into it. More than anything, though, we love SQL. RisingWave is just it's effectively Postgres compatible. And the abstraction RisingWave provided, it was they nailed it. You all nailed it there. It's exactly how we thought about our transformations here, and it made it really easy for us to get started. And the performance was really, really good. We could process thousands of rows a second, if not more. I think the most we ever pushed it to was like 15,000 a second, and it it just worked, and it was pretty reasonable cost wise. And so it was something that was like, well, all these things are pointing in the direction of RisingWave. Let's give it a shot. Um, so and more than anything, we didn't have to build the integrations. I don't know how many times everyone's integrated with OpenSearch and manage OpenSearch documents at scale. It's a pain. It really is. It's a struggle, and having to then push that data to BigQuery as well, and potentially other places that RisingWave integrates with. It was a no-brainer on that side. So how did
Yeah,
we do
quick
it?
question.
Yeah.
Sorry, Alex. I hate to interrupt again. Oh, by the way, I want to encourage everyone who's on the webinar. This is the time to ask good question. Anytime you have a question, please go ahead and post the questions and Q&A. I do want to ask you a quick question here. Awesome to hear your rationale behind picking Rising Wave. It aligns very well with the core design principles we have behind Rising Wave, right? Like in terms of Postgres compatibility, um, complementary nature in terms of data platform, adjacency to popular frameworks and things like that. Now, when you were exploring technology choices, did you have like a set of criteria like business and technical like check boxes? Like these are the things, specific criteria you had, or more driven by like once you tried Rising Wave, was like, yeah, or was it? I think that the process is very important because some people come with like a strict guide, a set of criteria we see with customers versus some who say, hey, well, we're going to try and see because they're not sure exactly like even the criteria they want to have, right?
Yeah.
I just wanted to unpack that a little. I want you to unpack that a little bit.
Yeah, we had a set of requirements, right? Performance was a big one. We wanted to get that time to the presentation of this actual data and the updates down significantly from the multiple minutes, if not longer, that it was taking in the previous infrastructures, previous platform. So that was a big driver of us for us. The other was ease of integration, right? We wanted to make sure we could integrate this relatively seamlessly into our platform. Um, I wouldn't say RisingWave is like easy, right? There's work there. We spent a lot of time uh, figuring out how to do this well. When I'll get into some of the places where we didn't do it well to start in a minute. And so kind of DevX, right, was a big part. We're a pretty technical team, but we're a small team. So making sure that we're able to manage this and kind of keep the plate spinning, right, was really critical for us. Um, I'm sure there were others at this point. It was 2 years ago, so remembering all the salient details is maybe a little bit more difficult. But um, we definitely all the things I mentioned a few minutes ago of that it just works with Postgres, right? We're a Postgres shop already. That it just kind of integrated into our existing tool set was really really valuable for us, right? That was a big unlock for us.
Yeah, I think for us, we focused less on the bells and whistles, to be frank, more on the um, foundation. So in a way, the fact that you guys started journey 2 years back would probably have a lot of the rough edges, which have been addressed now. But I want to hear then how your journey was. I think that's going to be a great segue.
Yeah. So I'll start with where we started. We tried to keep it really, really simple, not too simple. And we started with one schema. We started with just a handful of views, CTs within those views, kind of keep things relatively small and concise. We over provisioned the cluster. We spent more money, right, to get things going, manage amplification issues, and we basically manage updates manually. And it worked. It really did. It worked. We had that magical moment of you make update, one source makes an update to a particular person's details, and before you're even able to go and click to refresh the page, the data is updated, right? It was magical. It was really fantastic, but it was painful to manage. It was not the easiest system we had built to support and change, and there were a lot of reasons for that, right? Um, some of it was more organizational. One schema was not enough, right? Schemas are great. Allow you to organize things logically, and they're free. And so we really didn't use them correctly. Um, CTEs presented performance problems for us. We really didn't know that. We didn't understand all the details at the time of why those didn't work or why other versions were more performant and other approaches were more performant in RisingWave. Cost was a part of this, obviously. We were spending a lot of money on this, on an inappropriate amount of money for what we were doing. Um, we had really hard time managing access credentials. Now this was less about once it's deployed in RisingWave, but how we manage those and integrated those through our process was more difficult for what's the API key for accessing search, right? Um, Materialized views that were not at the bottom or maybe the top, I don't know, of the end of the DAG, right? The leaf nodes of the tree. Um, they weren't able to be changed, right? Without significant rebuilding downstream of those dependencies. And those changes, by extension, caused significant downtime for end users, which meant we had to do them off hours, whether it was on the weekend or at night, which hurt our engineers' sleep schedules, mine particularly. Uh, so we took a fresh look. We started over. Uh, and this was all running in production. So we couldn't just absolutely tear it down. We couldn't just start over from scratch. We had to figure out how do we get to the end result we want without breaking everything in the process. Um, so we're a Ruby shop at GDU Labs. That's what our main application is built in. And so we reach active record, which is the ORM of choice in the Rails world, the Ruby world. And since RisingWave is Postgres compatible, a lot of it just worked, which was great. Certain things didn't, and we found those very quickly. But we had a good starting point. We were able to get going pretty quickly here. And once we figured out what features that RisingWave doesn't support, things like transactions, foreign key references, and other unsupported features, turning those off was very easy. It was making sure we had the full set, right, and knew what we couldn't do. We also had features that RisingWave had that either Postgres didn't have or doesn't have, or more likely Active Record just didn't have support for built in. And so we added support for those. Structs is a good example. The way RisingWave handles exceptions is a little different than Postgres itself. And then subscriptions. was another feature that we were pretty heavy users of in RisingWave that didn't have an analog in Active Record and Postgres. Um, and then we got started on the DevX side of things, right? What are the helpers we can build? What are the tools we can build to make the migration process easier when we need to make changes, right? That includes how do we make sure secrets aren't in code, right? That's never a good thing. We wanted to make sure we could manage those via environment or configuration variables that were passed in at application runtime or migration execution time. And then we needed a pretty sophisticated test harness. We needed to figure out how to have really good test coverage of what existed so that when we made the changes we wanted to make, we knew we weren't breaking things. And because that RisingWave was all asynchronous, uh, we needed to build a bunch of functionality there on top of what is already available to us in the existing platforms.
So one question I have, Alex, because this is important, right? Like I think you've given us a lot of like candid feedback about why it's challenging, right? So, especially when you're onboarding to a new data platform, there's never going to be 100% match in terms of what the platform brings. There's some new things that probably new for you to take advantage versus some gaps that are obviously you have to adjust. So it's going to be a challenge, and I love the way you put it here. Um, just selfishly speaking, maybe a slightly open-ended question. Was there something we could have done in terms of documentation, feature set, processes that could have helped you, maybe made things easier, without you having to figure out on your side,
Yeah,
which I think we
yeah,
can
it's a
never
great
get to it.
question.
Yeah,
Yeah. I think documentation can always be better. And not that's just not just a Rising Wave thing, that's a general belief. There were definitely parts of what we were trying to do, problems we were trying to solve in Rising Wave that didn't have like a direct analog in documentation. We had to figure it out ourselves. Part of that is because of the relative newness of Rising Wave, right? These patterns hadn't been established yet. And I'll get into one in particular that we tried to figure out that is now in documentation rising, which is great. And there's always opportunities to share more of that and make it clearer what is possible and what kind of problems users are solving with the tooling that's available. At the end of the day, the tools that were available, I guess for lack of a better term, my son's a big Lego kid. So, the Lego blocks were there, right? The building blocks were there. The kits that you can buy, right? Maybe weren't there and are absolutely more so there now. I think finding more of those, finding ways to put those blocks together in different ways that solve different problems is is where I always find it to be really helpful from a like an engineering perspective. That's where you get a lot of, okay, I get it, that aha moment of great, you have all these disparate things. How can I put them together to solve a particular problem? And then people can pattern match, right? That's how I always learn how to use new technologies is I pattern match. I look for ways that, all right, well, this is a kind of similar to the problem we have with one subtle difference. Well, then maybe there's a way we can use that pattern, right? Um,
got it. Thank you.
yeah. Um, so we started with a bunch of different changes, right? More organization was a big one. We added more schemas. We broke things down better. We broke things apart pretty quickly. We took one materialized view that had, I don't know, a half a dozen kind of core things in it, or three or four more core things in it, and we broke them apart into three or four different views that all depended on each other. It allowed for better parallelization within Rising Wave, which was going to improve streaming better, improve streaming, as well as improve the backfill process when we need to create new things. Most importantly, though, the biggest aha moment for us was breaking apart the DAG. Our graph was not massive, but it wasn't small, right? I think we're, I don't know, maybe 50 or 60 different relations, um, all we had the kind of four pillars, right? We have the locations, the organizations, the people, the employments, but there's interconnectedness between them. Obviously, employments relate to organizations, right? And people have locations. So there's a lot of dependency between these different relations. So at a very high level, here's where we started, right? We had our upstream data, we had our intermediate transformations, our filters and things like that we did to that initial data set. throw out the discarded rows, the soft deleted rows, things like that. And then we had our final downstream sinks. This is an oversimplification, but generally directional. Um, and so we had our downstream people, and we had OpenSearch, we had BigQuery, etc. We had subscriptions downstream of this as well, and it worked great until one of these, I guess, bluish purple boxes needed to change. If we needed to change location layers, the intermediate transformation there, everything downstream of that had to drop and get recreated, which is inconvenient, right? So it's inconvenient from a downtime perspective because we want to make sure we don't miss any data changes, particularly deletes. Deletes are always the scariest one to manage. You don't want to risk keeping data around that should have been removed. But also it was time. We had to manage the process of changing it. So well, we took a step back, and I say we importantly because it was not just me by any means. There were a lot of people that spent time on this, and we tried to figure out what are the common cases for changes, right, that happen in the system, and can we optimize for them? So what's really common is the data changing, right? That means like the implementation of a particular aggregation, right? But the type of that aggregation doesn't change all that often, right? New columns happen fairly regularly, but deleting columns, removing them, pretty infrequent. And changing the structure wholesale, very infrequent. So we tried to optimize for the common case. We know we're still going to have to do the not so common case work. It happens, but it's way less frequent. So let's not prioritize it. So we leverage table syncs. Table syncs are a feature of RisingWave, which is essentially like an external sync that just goes back to RisingWave, right? It breaks apart the structure of the data from the data definition itself. And so you can modify the logic of the data that's generated without changing the structure, and the downstream dependencies are on the structure, on the table, not the sync itself, not the generation of the data. That combined with on conflict statements enabled effectively zero downtime changes for us in a lot of places. Um, it also enabled us to use multiple syncs to a single table, which is a huge benefit when we're talking about kind of disparate data like in OpenSearch that needs to be denormalized and sent all in to a single place. But more important than anything, it allowed us to break apart the dependencies. That is a huge benefit for us and for our team and for the way that we roll out changes. So what does it look like? It's a more complicated DAG, right? There's more logic here. Usually, things that introduce better functionality and add more complexity. In this case, that absolutely is true. Instead of one relation, you have two in a lot of places. You have the table that has the data in it, and you have the sink that fills the table. And so what was really nice about this is if we want to change how the location layer data is filtered or transformed, the only thing we have to do is change this one. We don't have to change anything else, which is really, really nice. So to give an example, some actual code, this is an oversimplification, but previously, before a table sync, you'd essentially have a materialized view that looked like this, right? You create your view, you select from a particular table, you filter the things you don't care about, you do all kinds of transformations, you rename things for improved joining, efficiency and all that other stuff. Great. That's cool. Really simple. A table sync kind of splits it in half, right? You define the structure with the table, you define the on conflict statement for the version, so that you can create multiple of these and have them not conflict with one another. And then you create the sync that goes into that table, right? So for anyone who's used Postgres, and hopefully if you're here, you probably have, the create table is very, very standard. There's nothing special about this with the exception of the on conflict statement. The sync is almost identical to the materialized view, with the exception of you tell it where to sync the data to. And we're adding this version column. Why this version column? This is what essentially tells RisingWave if we introduce V2, if there's ever a row that has a V2 and a V1 tries to write to it, it drops the change, which is really, really helpful. So we rolled this out in a lot of places, not everywhere, but in places in particular that were really they were depended upon by many different other views, other relations. those are where the value was incredibly high for us. Um, we kept some things the same, right? We kept relations that just do select accept kind of things as just views, relations that kind of prepare data for external syncing. There's no reason to have a separate table for. Um, and there is an overhead with having a table sync. There is, it's not all good. There is a downside when it comes to essentially doing primary key lookups and all of that. But overall, we were able to apply it to a lot of places throughout our DAG. It made changes way easier. It was way less stressful and way less management that was required to make these changes, particularly as we were continuing to quickly iterate on what different aggregations we wanted to do. We were dropping and recreating these things relatively frequently. And then we shared this pattern with RisingWave, which was great. They were really helpful. All the people that we worked with at RisingWave when we were trying to experiment with this locally and see if this actually solved the problem we had, and make sure that doing this didn't introduce some crazy bad problem downstream. And so it was really great to work with Rais's team on making sure that this process and this pattern actually solved the problem we had.
Yeah, so I think I want to compliment you on like the creative thinking behind, because all the things like from an engineering perspective, when you're so close to the code, we don't realize that some of the, we have the view that okay, we're not a, whatever the original design is, we're so familiar, it doesn't occur to us that there may be this blind spot there in terms of how to solve some problem. So the fact that you guys shared and proposed rather than just take what was there in the product, right? That's sometimes that's why I call this a partnership as opposed to just a customer who's just like taking it from a vendor. So I just wanted to, not a question, but just wanted to compliment you guys on that.
Appreciate it. Yeah, we've always really enjoyed working with the RisingWave team. We've worked pretty closely with a bunch of different engineers over on the team that have helped us debug things, but also helped us think through different approaches to solving problems, which has been really helpful. Finding ways to leverage indexes where we didn't realize how we could do that, and finding ways to codify this pattern right into documentation. There have been numerous places where in times where we were at a loss for how to solve a problem, and there was this great idea that came from the RisingWave team. It's great that sometimes the reverse has happened as well, and it's been a really good partnership in that way. So what else did we do? This wasn't it. This wasn't the only magical solution to our RisingWave problems. There were many different other features of RisingWave we didn't use upfront or didn't exist yet. Unaligned joins was one that didn't exist. That has been a nice benefit for us. We definitely have join amplification problems on hotkeys for our workloads in certain cases. Best example is imagine IBM's details change and we need to copy that data down to the people that have worked there in the past for improved search performance. That's a could be millions of people. Unaligned joins help mitigate that at least to a certain extent to ensure that the cluster stays healthy. Indexes is a great one. That was is a relatively new one for us. We're Postgres people. We're familiar with indexes in general, but the way they work within RisingWave is different and extremely powerful. And we didn't know that up until October maybe of 2025. We didn't really understand that. And I think if we had, it would have improved our process for managing this data and rolling things out even more, um, because it essentially is another table. It's just the locality of the data is more efficient for the way it's read. And that's true for streaming and performance. It's true for backfill performance. And it essentially eliminated mostly random reads, which is always better. And so that was really helpful for us. Backfill control is another one. Um, and more importantly, the locality based backfill, it's relatively recent. I think it came out maybe one or two versions ago, is really exciting for us because we have a lot of the locations is a great example for us of there's only maybe a million different locations or 2 million locations on hundreds of millions of people. Being able to backfill data there is very spiky if you don't do it in the right order. And so having that control is really helpful. And then I alluded to it earlier, but wide tables is a pattern that I think it's I think originally it's actually a snowflake pattern, but RisingWave has a approach to solving that as well, where you can take disparate data that all shares the same key and send it all to the same place, which is really powerful for us, particularly for the search scenario, where you part of the benefits of open search and everything is leveraging denormalization, right? And having various data that's not really related, but all has the same key pushed to the same place, allows us to parallelize the materialization process while putting it all together at the end, which is great. Additionally, we learned a lot about the configs, the switches, the options of RisingWave for management sake, right? Being able to roll out changes. Sometimes some changes are more uh, cost effective or efficient than others. And we want to be able to roll these things out safely during business hours. I don't want to be up in the middle of the night doing this if I don't have to. And I don't want my team to do that either. And so learning how to take advantage of these options was really important for us. Controlling the source limit is a great one that we don't end up with what is effectively a thundering herd of updates if there is a problem. When that problem abates and all of a sudden there's 50,000 rows to process upstream, you don't want to try and process all of them up front, right? You want to try and drip them and catch up. So that's a great quality of life improvement for us. Being able to control parallelism of our different syncs, external syncs in particular. We don't want to overload OpenSearch by sending 500 concurrent requests to the cluster at once. Being able to manage that is really helpful. And then being able to manage the backfill process when we make changes has been really, really helpful. And these are not new things. These have existed at least since we've used RisingWave in some form. But understanding the nuances of when to use them and why is something that has taken us time to get familiar with. Um, so what else we did? Subscriptions is a big feature for us. We use subscriptions a lot to know when updates we care about happen. And part of that is building the plumbing to manage that within our infrastructure. Um, RisingWave is great at managing subscriptions, at being able to fetch this data efficiently, but we need to make sure we track the progress, the watermark correctly, that we're resilient, that we don't hammer RisingWave for no reason if there's no updates, right? We kind of back off slowly and then we're able to observe what's happening. Observability in general was a big focus for us over the last 6 months, I would say. We always had observability in Rise. It was an important part of integrating with RisingWave of getting these metrics into other places, like Datadog, which is the observability tool we use. We spent even more time over the last few months really nailing that part of the process. And so good example, seeing what's happening in subscriptions, right? How far behind are we? And so you can see this is a snapshot from a few weeks ago, but seeing that we're well within our SLA, right, for these subscription updates of being 10, 15, 20 seconds behind the current time, which is more than reasonable for our use cases. And we can see the activity. We can see how many updates are we getting at any given time. And you can see they're very much correlated, right? You can see the volume. In addition, overall RisingWave observability was a big thing for us. RisingWave, we use the cloud tool, the cloud managed service from RisingWave, which has metrics and all of that. But being able to correlate impacts in RisingWave to our actual activity was really, really important for us. We wanted to know that this massive influx from one source of ours caused this effect in RisingWave. And having all of that in one place makes it very, very easy to do so. So we built various dashboards in in Datadog for RisingWave to see the cluster scale, see what our compaction systems are doing, how fresh are the streams. It's going to look very similar to anyone who uses the cloud tool or the cloud service or even the Prometheus built-in dashboards and all of that. And so we pull all of this stuff in and we're able to see it, but we're also able to alert on it directly through our existing uh, observability infrastructure.
A quick question here, Alex. Like, so the Prometheus Grafana dashboards that we have, which are pretty, almost developer centric, like there's a lot more details. Was that an overkill for you guys, or was that like, is this, how useful was that? Because that's
So
used
we're on
quite.
the cloud tool, so we can't really see those without. working with the team directly to get visibility into them. We get access to the metrics. We can push
Yeah,
into our own Prometheus, Grafana instances and all of that if we wanted to. We wanted one place, right? We wanted to have it in the same place our observability is for our data flow jobs, the same place as our application monitoring systems, right? That way we can see the correlations of this spike happened here that caused this activity to happen here, et cetera, was really important for us. And so um, getting it into Datadog was the key for us. We experimented with our own separate Prometheus Grafana interfaces and all of that, and we were able to see a lot of data. But in terms of what we were able to do with it, it only became really valuable once we got it into our existing tool.
got it.
So
Thank.
um, so another version of this, right? Another part of observability for us was amplification because of the nature of our workloads. We know that this is a something we have to be aware of. Knowing how many rows had amplification warnings, right? We pipe all logs from RisingWave into Datadog. We can index them and search them and alert on them. We can see, all right, there were 36 rows that had amplification warnings across all of those rows that affected 1.3 million downstream rows or whatever the numbers are, right? Was really helpful. In addition to knowing how far behind are we on syncs. We used decoupled syncs everywhere, right? So that everything's essentially buffered. But if that buffer is really, really backed up, that's a problem. We're not scaled appropriately. So making sure we know how far behind are we was really important. Overall, yeah, we're pretty happy. We've obviously been working with RisingWave for a couple of years now. I think it's will be 2 years in April or May in production, and as you can see, there were bumps. There have been bumps along the road, but overall, what we've been really happy to see is the rate of improvement and the responsiveness to issues that we do find and ideas that we do have. I think that's a really good sign of a great partnership, is seeing the willingness to experiment and try new things and try and solve problems for us that we can't solve on our own in the existing tool. So they've been really incredible to work with, and we've seen a number of changes that have either things that were already being worked on independent of um, our influence, and then we've been happy that we've been able to influence other features, and whether that's prioritizing things that didn't work up front or adding support for some new feature that's completely brand new or better documentation to your point earlier, Ais. Um, and it took some time, but RisingWave has definitely delivered on the goals that we set out for, which was the streaming updates with minimal or without the massive operational burden of doing all of it ourselves. And so that's been really great. So what's next? We're pretty excited about some of the changes coming. I know I should have updated this slide, but I think version 2.8 came out earlier this week, and I've not had a chance to look at everything that was included in it yet. But I do know that one thing that we're excited about there is the extension of backfill control to table sinks. That was only a thing that was available for views up until recently. That'll help us a lot for that pattern that we already mentioned. And while we don't anticipate brand new workloads coming to RisingWave for our use of RisingWave, we do anticipate the volume of our current workloads to substantially increase. And so we're excited to see excited, anxious, I don't know, to see what that means for our RisingWave infrastructure to go from we're expecting an increase of somewhere in the range of 3x our current data set. And so over the next 12 months. And so we're talking at that point somewhere in the 1.5 to 2 billion, 3 billion entities. I think that math is right. And so that we assume will have some impact at the very least in how we use RisingWave. But we're pretty excited about continuing that partnership for the foreseeable future. All right, that was it. That's all I got.
All
Yeah,
right, great.
yeah.
Awesome job, Alex. So I let me see if there are any. You did such a good job. I don't know if there are questions, which is always a good problem to have. But I do wanna, obviously, I wanna thank you for sharing your journey about how all the problems and solutions, and it's like I said, it's true 2 years, and we work with you. We work with you very closely, and we, one of valued partners that we consider you as. Um, and a couple of things I wanted to also ask, looking ahead, right? Our focus, although our core competency is stream processing, which is always going to be our, where we'll be focused, but the product also has evolved. Like we've added iceberg support. We're going into, we introduced some of the things into on the agentic side, like to run AI workloads. Um, does that in any way, are those in alignment, or do you see those as something that you will be of value for you for your team in the future?
Yeah, it's a good question. We've talked about there are a couple areas for us that are still very costly, as an example, that are continue to make us kind of revisit different ways we solve problems. BigQuery is a great example of that. BigQuery is really, really cheap for reading, is not cheap for upserting data. And we found ways to and controls to mitigate that and ensure we don't spend a fortune. But that's a big part of our cost right now. And finding ways to not have to do that. Iceberg maybe is a potential path for that. Um, that we're always looking at. We have to figure out how we prioritize it, but I think that's an area where we've definitely it's on our list as a known pain or limitation point that drives our costs pretty high, or at least disproportionately high to the value it provides. Uh,
Got
so that's one area. Definitely on the AI side, we've not experimented a ton with the AI. I think they're implemented as UDFs, right? In RisingWave.
Yeah,
Um,
we've added a bunch of features in terms of supporting native vector types, some whole bunch of functions to, if you're using basically for as a feature store, how best you can use RisingWave. And also on the agentic side, having a, we released the agent skills module. So from productivity perspective, instead of, from troubleshooting and
yep.
improvements on the developer DevX side.
Yeah,
Um,
we've done a version of that ourselves as well. We have a within our application that manages the Rising Wave cluster. We've got a skill or two for managing the and re-implementing or changing the patterns we have that we built out. So that table sync pattern is a good example. How do you add a new column through the entire materialization stack? Let's let AI do that because now that we have several examples of the pattern, AI is pretty good at doing that implementation. So we've definitely gone down that path over the last couple of months. More to do there for sure. And then obviously figuring out how do we leverage if we leverage AI within RisingWave itself rather than just for managing RisingWave.
Got it. Yeah, and
Um,
then going back to your previous point about BigQuery, right? So if you exploring serving workloads, right, especially with the data fusion query engine on Iceberg, which released in 2.8, I would highly recommend. If you wanna try something, that would be a good starting point. Um, okay, looks like there are no questions. I again I appreciate you spending time, sharing amazing presentation. So looking forward to continued partnership and feedback, candid feedback as you always given us, Alex, and want to thank you again.
thanks, Race. Thanks,
Hey,
everybody.
bye bye.